Okay, so we will continue on our journey here with displacement time graphs. Just a quick little review. Okay, so today in blue there, calculate instantaneous velocity from a DT graph. We've talked about time interval. Okay, great. Now it's time to put it away. Now I'm going to go for a while, but now it's time to stop that crazy calculating that you're doing there, right? Adding numbers just can't help itself, can it? Yeah. Okay, so we talked about time interval and time instant, and so far we've determined displacement from a DT graph. How do we do that? Read 2 points off a graph and subtract, right? Remember the displacement, the position is the y here, right? This thing here, right? And we've also determined average velocity from a DT graph, where we divided the displacement by time interval. And I sort of showed you, I don't know if I actually formally told you, but I sort of showed you that it's really the slope, right? Because when you take the displacement, which is the change in y, and you divide by the time, which is the change in x, change in y divided by change in x, rise over run from the math world, we call that slope, right? So that's a little review there. So now, today, we're going to look at instantaneous velocity. So even before I begin, what do you think instantaneous velocity means?
Velocity
At a certain time on the graph, right? One particular time, not over an interval, one instant. I'm not sure what the graph there is for. Let's go to the next page to see. Oh, okay, I guess we're going to review first. Okay. This is what you guys have? Yeah, you do. Okay, good. Okay, so find displacement average velocity. You know what? How about just try that? Okay? Just try that as a quick review while I do attendance, and then we'll confirm that you guys know what you're doing there. So there's, to find average velocity, you have to find displacement. So for each one, you have to find the displacement and the average velocity slope. You might have a question about part F. That's okay. Did you get 3 meters per second for the first one? Right? Displacement, it goes from 0 up to 6. Time is from 0 to 2, 6 divided by 2, 3 meters per second, right?
Sure.
B, did you have to calculate? I hope not. When it's flat, Brody, what does that mean? What is 0? Yeah, not moving. Velocity 0, right? Flat line. 0 meters per second. Displacement is 0. C is down. It's negative, right? 6 to minus 10. So what's that? Minus 16 is the displacement. And the time is from 6 to 10. That's 4. Oh, that works out nice. Minus 4 meters per second. Okay, let's look at D. Hey, D's another flat one, isn't it? 0. That's easy. E. From 12. Did you notice that the time is even given to you right here? Like you could just do the subtraction right there, right?
Yeah.
Like this is going to be over 1, right? Okay, so it's from minus 10 to minus 4. That's plus 6, or 6 over 1, 6 meters per second. Mr. Bennett, can there be like 47 of these questions on the test? This is easy. Right? There won't be. Oh, now what do you do with F here? Is there anything, Renee, do I need to get excited? Do I need to worry about this? Because it's curved? Do I need to do anything different? It starts at minus 4, it ends at 0, so that's up 4. And the time is from 13 to 18, which is 5 seconds. 0.8 meters per second. Does it matter that it's curved? What does it mean that it's curved, though? Because we sort of talked about that the other day with my little cart thingy, right? It means it's deceler. Is it speeding up or slowing down? What do you say, Dad? You say slowing down. Why? Slope's getting flatter, right? Slope's getting flatter. I like to say the slope is approaching 0, so it's getting slower. You're right. Now, it doesn't matter, but if you were to draw this line right here, and I didn't draw it very straight, so I'm going to start again. If you were to draw that from there to there, what would the slope of that line be? Austin, what would the slope of that line be? 0.8, right? Okay. So I've connected the endpoints, you might say. Okay. In the graph, the slope of the line at time interval A would yield the average velocity, blah, blah, blah. This is true for straight lines and curved lines like interval F. Speaking difficulties today. Okay, so instantaneous velocity is the slope of the line at a single point. The slope of the curve at a single point. A time instant. I hope you have that on the next page. You have to fill it in, it looks like, at the top of the page. It says at the top of page 2, instantaneous velocity is the slope of a line at a single point. In fact, you know what? I'm not liking this. Can I change it to the slope of a, how about dt graph? I think that's better. The slope of a dt graph at a single point. Slope is always velocity of a dt. Sorry, velocity is always slope of the dt graph. Now, if it's straight, does the slope change at all during interval A? Does the slope change? That's what straight line means, right? It means straight, slope is the same. The slope is the same. So the slope here is the slope, there is the slope, there is the slope, there. You just find the slope, and that's the average velocity. What is the slope of A? We already worked it out. It was 3. How fast is it going at, I guess, 0 time? It's going 3. How fast is it going at 1? 3. How fast is it going at 2? 3. That entire interval, it's going 3 every instant. Constant. What? So it's easy for straight line saying it's just the slope of the line. Okay? What about, here it is here, V inst is the slope of the line since the slope remains constant. That's what I was just saying. What's the next follow-up question? What about the curve? Okay? The top is the same, I just changed the side of it. For curved line segment F, V inst, instantaneous velocity, is the slope of the tangent line. What does that mean? Slope of the tangent line. Okay. Have you guys heard, is that in grade 11 math? Grade 9, really? Okay. Grade 9 geometry. Slope of the tangent line is the line that touches the curve once but never touches it again, right? So it's kind of like something like that, Dan? Physics professors, math professors with a lot of hair, especially coming out of their ears and funny glasses, bad clothes, like to say that it approximates the slope of the curve. It's an estimate. It's an approximation of the slope of the curve. And as you go up, that tangent line does what? As you go up the curve, like if I go up here, oh, come on. If I go up here, what do I have to do to the tangent line? I've got to make it flatter, right? That, my friends, is a key idea from calculus. When you start taking calculus, Mr. Ray, in a couple of years, or even in university or whatever, because you're all taking Greek calculus, right? So you can take calculus, right? Everyone does. You'll understand it, okay? It's called a limit. But anyways, for us, we're going to do it geometrically. So the instantaneous velocity is the slope of the tangent line. How do you find that slope of the tangent line? The slope, how do you find the slope of the tangent line itself? How do you find the slope of a regular line? Exactly the same thing. You guys know how to do this. You just pick 2 points and find the slope. How do you know where to draw the tangent line? How do you know where to draw the tangent line? Well, you have to estimate, okay? Braden's going to get a slightly different answer than Andrew and Alex and Dan and I picked all boys there for some reason, like Avery and whoever, Bailey. You're all going to get slightly different answers, but it doesn't matter. What matters is the process. Okay, now I don't know how much you have to fill in there, but I know there's some, so let's do this to start with. So finding instantaneous speed using tangents. There is a tangent line. Okay, the green line. So you draw the tangent line. Should you use a ruler? Yeah. Does it have to be a ruler, or could it just be some straight thing, like a calculator or phone? That would work too. Okay? The tangent line only touches the curve at one point and estimates or approximates the curve at that single point. Okay? And the slope is delta y over delta x, or y2 minus y1 over x1. So in this case here, you draw this green line, you pick 2 points. Now, the common misconception is you have to pick the endpoints. Is that true? No, any 2 points will do. Any 2 points will do. So this y value here is 10. This y value here is 5. 10 minus 5. This x value here is 9. This x value here is 5. So I get 5 over 4, or 1.25. I don't have units, but we'll...
That y value is 2, not 5.
Yeah, 2.
Oh, yeah. Why did I go 10 minus 5? I must have assumed it was 10 minus 2. Thanks, Dan. So that's going to be, 8, Ed, isn't it? 8 over 4, or 2. So what did we do? What were the steps? We're finding instantaneous velocity of a curved line. So you draw the tangent line, pick any points you want, find the slope. That's it. That is it. Okay? So the instantaneous velocity is the slope of the tangent line. Rise over run if you prefer. Pick any 2 points of the tangent line to find slope. Does not have to be the endpoints. Does not have to be the endpoint. When the dt graph is curved like this, this is called variable motion because the velocity varies. This particular one is curving up. What does that mean for my velocity? What's it doing? Brandon, what's the velocity doing here? Don't know? Remember the other day there? We were playing with the cars, right? Here the slope. Where is the slope the steepest, Brandon? At the start or at the end? Okay? At the end, yeah. It's really steep. Look, it's almost like straight up and down there, right? Here it's flat. So is it speeding up or slowing down? Speeding up. Because the slope is getting steeper. Okay, this one here is speeding up. Give me the nod. Yes, I get it. What a great thing to learn on Monday morning. Yeah, probably not so much nodding there. It's nodding, it's just nodding off. Jolly good? I'm making sense? Okay. Just checking. Okay, what's next? Oh, there's practice number 1. Okay, so you've got a little graph thingy there. I told you the point. It's at, well, we wouldn't even know what time it is, right? Okay, so you have to draw a tangent line, pick 2 points, find the slope. Go. Draw a tangent line, pick 2 points, go. How's that for a tangent line? It touches the curve. Actually, you know what? I'm not happy with that. It should be a little more flat. Again, I don't care how close you. I mean, there's a limit to my reasonableness, but I'd like it to be a little bit flatter, I think. Right? It's got to match the curve of the line. Okay? We're going to go with that. As long as I see a tangent line, and I see that you've shown me 2 points. Let's see if we can find a couple points here. I'm going to go with this point right here. And I'm going to go with... having a hard time finding another one here. So I'm just going to pick any old one. Okay, so I'm going to say these points here are at 8, 25, and this one here is at 1. I'm going to say 12. Is it okay if you get different points? Yes. find the slope, change in the y's, 25 minus 12 over change in x's, 8 minus 1. 25 minus 12 is 13, 8 minus 1 is 7, and I can't do that in my head. It's a little less than 2. I get we'll say 1.9. 1.9, and it's meters per second. I'll likely take anything from about 1.4, 1.5, something like that, all the way up to about 2.4. If it's more than that, if it's outside that range, then I'll have a closer look and debate whether or not you know what you're doing or not. The more information you can give me to make me understand how much you know, the better off your chances are. What's one thing you can do to tell me that you know what's going on? Mark those points, maybe give me the coordinates, something like that, right? If all I see is an answer, if I just see 2.8, no tangent line, no points, well, my best guess is you looked off your name. Sorry. Show your work. Try another one. This one always causes a little grief. I've upped the ante a little bit here, a little bit harder. Does it matter that this tangent line might cross the graph further down here? Does that matter? Because Dan said the tangent line touches the curve once and never touches it again. It's not exactly correct. It is the same graph, but it's not part of it, right? Like, it's not even close, right? So is that okay? Absolutely, right? Like if, for example, if this graph, for whatever reason, went up like this and then down like that, right? And this continued on, is that okay? Well, yeah. I mean, this has nothing to do with this part, right? Okay, so find your 2 points. Again, doesn't have to be the end point. It can be any point you want. Look, you know what? Just because I'm going to be like this, I'm going to pick 2 points down here. I'm going to pick that point and that point. I am going to explicitly show you it doesn't have to be the end points. It can be both be on the left-hand side of the point. So I'm going to say that is like, I don't know, 13 minus 9 all over 4 minus 2. 4 over 2, did you get around 2? Right? Around 2, anywhere from 1.5 to about 2.5. It's that simple. That's it. Okay? The other day when we had the carts out, right, and we accelerated, we saw that increase, right? So here we've got a graph. So find the v in step 1, 2, and 3 seconds. So you're finding the slope right there, and right there. And your numbers should do what? Get increased, should be bigger, right, as you go. Okay, you got 3 to do there. You got to draw a line for each one of them. If you want to draw each line first and then your slope, that's fine, right? But your slope should be increasing. Go ahead. To find, some of you didn't even get that far. Right? You literally take a ruler, not a timer. Or a straight edge, and you have to match the curve. Right? You put your ruler up, and it's got, like, how's that for this point right here? Like, look at it this way. See how fast the ruler pulls away from the curve here? Can you see the gap? Well, what about on this side? Is it doing the same thing? It's not, is it? So that tells me that I got to go that way a bit, right? Like the gap on either side, the gap between the ruler and the curve should be about the same on either side. Is that better? I would say so. Does that make sense, right, what I just said? The gap on either side? Do you know what I mean? Yeah? Are you just saying that to make me feel good? You sure? Okay. And then you draw your line. And then here's the other problem that people had, and I'm not convinced, I think it's just laziness, is that people didn't figure out the slope. I'm not sure what the problem is. How do you find the slope? You pick 2 points, and again, it doesn't matter what your lines are. Okay, like there's a good one right there, right? It's right on the grid. Right? Look at that one, see? 1 and 0. Let's see if we can find another one. No, it doesn't look like it. So pick some other point. You're going to have to get. Is there going to be some estimation here? Absolutely. So I'm going to call this 1 and 0, and this one here is going to be 2.5, and we'll say 1.8. Okay? And then we're going to go 1.8 minus 0 all over 2.5 minus 1, which gives me 1.8 over 1.5. Is it important to show your work here? Yeah, because again, you're trying to convince me that you know what you're doing. I deserve marks here instead. I know what I'm doing. 1.2 I got. Okay? Yeah, good? Okay. There are now, at the end of this booklet, there are, I think, 4 graphs. Am I right? There's 4? There's a lot. Right? Graph A, B, C, D. Okay. You'll notice that the first one has no curved line. Easy, right? If you think you're beyond that, you're beyond level easy, go to graph B. If you need a little practice, do graph A. Graph B has 1 curved line. Graph C has a curved line. You do what you need to do to learn how to do this, right? If you know what you're doing, do as little as possible. If you need lots of practice, there's a lot there. If you really need more after that, I'll get you more. But don't say, I don't know how to do it, and then not do any. Because that's the exact wrong thing to do. Okay, I'm going to give you some time to work. Use it.